Lesson 11.4, we're going to look at geometric series now. 11.1 we did arithmetic sequences, and then we did in 11.2 arithmetic series, which are summing up so many terms in an arithmetic sequence. 11.3 we did geometric sequences, which you're multiplying between terms, unlike arithmetic, where you're adding between terms. And now in geometric series, we're going to be summing up the terms of a geometric sequence. So that's the definition of geometric series right here, the sum of a geometric series. You're summing up so many terms, n number of terms. So there's some formulas that we're going to deal with. There's actually two formulas here, and I want you to notice for these two formulas, they are pretty much the same. You have 1 minus r on the bottom. Remember, s sub n means the sum of n number of terms. Now this is for geometric. Okay. If you look at on the bottom one, if you distribute a1 to those terms, you get that. So this one just has it in parentheses. Sometimes, depending on the given problem, it's easier to use the top one. And I prefer the top one, but there are a few occurrences where maybe the bottom one might be a little bit easier. But they're really the same formula other than the a1's distributed on top, and it's kind of factored out on the bottom one. So, first problem asks us to find the sum, s sub n, of the geometric series with the information given. We're trying to find the sum, s sub n, given a1, which is our first term, r is 2, that's what we're multiplying by, between terms in a geometric sequence, and this means n is 15, we're finding the sum of the first 15 terms. So let's use the formula. I'm going to find s. Now it says s sub n right here. I am going to use s sub 15, which means n is 15. And then I'm going to use the top one there, so a1 is 2 minus 2 times r, which is 2, to the n power, which is 15. And then on the bottom, we have 1 minus r, which is 2. So I am using this top formula. I just plugged all my values in there. Now you really have to understand order of operations and what you need to do first. I would not round anything off, especially when you're dealing with r being a fraction. I would always convert to fractions on your calculator. So what we're going to do, obviously on the bottom, I'm getting -1. So what I'm going to do on the calculator right now is type in that line right there. So let me pull up my calculator. I'm going to do 2 minus 2 times 2 minus 2 times 2 to the 15th. So let's pull this up. I'm going to do 2 minus 2 times 2 to the power 15. Okay, so I'm doing the top there, and I get negative 65,534. So let's go back to this. That top gives me negative 65,534. If I divide by -1, obviously the two negatives cancel out. It's 65,534. And that would be the sum of the first 15 terms. Now if you started listing them out, a1 is 2. a2, we're multiplying by 2 between terms, so it's 4. Then 8. Then 16. Then 32, and so on. There's the sequence, and we'd list that out to 15 terms, and you'd add all those up. But this is the formula for actually finding the sum without having to write them all up and plug them all into your calculator and add them up. Now we'll get back to segment notation, which we dealt with in arithmetic series. Remember the formula for nth term of an arithmetic sequence from the last section, 11.3, was a sub n equals a1 times r to the n minus 1. That's really what we have right here. This is that sigma symbol like we dealt with in the arithmetic series. This right here is a1. R is this number right here that's raised to that n minus 1 power. So when you're doing segment notation for geometric series, that's going to be the case. And the bottom number here, This is a little different than arithmetic. We'll always start at the value of 1 for the variable. Because if you notice, if you plug that in, you'd have 1 minus 1 for the power, 2 to the 0 power, which is just 1, 3 times 1. So the first term would be 3. Okay, you get a 0 power there. So we're going to use the second formula on this one. Okay, the one that's got the A1 factored out in front. So I'm finding, now you're going to find n kind of the same way we did before with arithmetic series. To find the number of terms, n, you take the top number minus the bottom number and add 1. So finding n in segment notation here is just like it was for arithmetic series. So I'm going to do 12 minus 1 plus 1, which is going to be 12. So there's 12 terms. So I know n is 12, I know A1 is 3, and I know R is 2. So I'm using these three things right here, and now I'm going to plug into this formula. So I'm finding the sum of, and I'll just call it S sub n. I mean, it's really the sum of the first 12 terms. We're going to take A1, which is 3, times 1 minus 2 to the nth power, which is 12, so that's in parentheses, all over 1 minus 2. So what do we get? I am going to, on the bottom, you can see 1 minus 2 is negative 1. So I'm going to type in that top line on the calculator. 3 parentheses 1 minus 2 to the 12th. So let me pull up my calculator. 3 times, and then 1 minus 2 to the 12th power. And I'm going to hit equals. So that's negative 12,285. So negative 12,285 divided by negative 1, that's 12,285. There's the sum of the first 12 terms for that sequence in segment notation for a geometric series. Now, there's an alternate formula. This is the alternate formula. So another formula, and you need to know how to use the alternate. Now, this one is different. We're going to use this one if we do not know n. Okay? Usually this means you are given the last term, a sub n. Remember, an is the last term. So usually if we know the last term, we're going to use this one. And we don't know n. Notice there's no n in this formula. Okay, so we can't, if we don't know n, we can't use that other formula. We don't know n, so we're just finding the sum here. And if you notice, here's what we're given. A1, we know. We know the last term. And we know what R is. R is a fraction here. Okay, that's what we're multiplying by between terms. So obviously, if A1 is 7,776, and the last term is 6, okay, it's getting smaller. Okay, and we're multiplying by negative 1/6 here. So let's go ahead and plug things in. We're going to put A1 first. A1 is 7,776 minus AN, which is 6, times, so that's the AN, times R, which is negative 1/6. And on the bottom, I have 1 minus negative 1/6. Now, you got to be really careful with your calculator. I am going to type in that top line on my calculator. So I have 7,776 minus 6, and I like to hit my time symbol in between and then do my fraction inside parentheses. So negative 1 divided by 6. So there's the top. Let's see what that's equal to. 7,777. So on top I get 7,777. Now I take 1 minus a negative 1/6. That's 1 plus 1/6. So if I actually do that, that's 6/6 plus 1/6, which is 7/6. So I'm going to divide by 7/6. Do not round off any decimals. You need to enter them as fractions on your calculator. So let's go back to the calculator and divide that 7,777, which is already in there. I'm going to hit divided by, and then in parentheses, 7 divided by 6. You cannot round off decimals, otherwise you won't get the proper sum. So we get 6,666. There is the sum for that geometric series. Alright, we got one more example left here. Specific term. We're finding the first term, A1, which we know the sum. Okay? The sum of the first 8 terms, which also means that n is 8, and we know r. Remember, this is S sub n. That means we know, that's telling us, even though they don't say n is 8, you have to indirectly figure that out or realize what that means. Okay? So we're going to use the one that's in factored form, and this is where that one is a little bit easier to use. So I know, if I use this formula, I'm going to do S8 on the left, which actually is 765. So I'm actually putting that in over here, what that's equal to. So 765 is equal to, we're trying to find A1, so A1's going to go there, and then it's 1 minus 2, and n is 8, because they told me the sum of the first 8 terms is 765, so n has got to be 8, so we're going to put 8 right there, all over 1 minus r. Now we're going to solve for A1 to find the first term. So let's do some things here. Let's get 765 equals A1 times, I'm going to actually figure this out on my calculator, and then on the bottom, 1 minus 2 is negative 1. So let's do 1 minus 2 to the 8th. So let's pull the calculator back up. I'm going to do 1 minus 2 to the 8th power. So that's negative 255. Okay, a couple different ways you can do it from here. Basically, your two negatives will cancel out here. So here's what I have left. $765 equals A1 times 255. Well, now I'm going to divide by 255. So if I take 765 and divide by 255, if I go back to the calculator, 765 divide by 255, it divides into a whole number of 3. So A1 from this, A1 is equal to 3, which means my first term is 3. So that's kind of working backwards in the sum formula, or one of those sum formulas. And that is lesson 11.4.